Okay, good afternoon, everybody. So two-way ANOVA, when we have ANOVA with two basically factors or two sets of populations. So there are basically two scenarios. One is between these two factors, one factor is a block factor. By that I mean we are not interested in investigating the effect of that factor, but that factor affects the homogeneity of the study. For example, we want to see the effect of different type of solutions. We cannot do the experiment in one day. We have to do the experiment in 4 different days. And that's why days is another factor which basically would affect or could affect the homogeneity of the experiment. So what we need to do, we need to separate the effect of factor from the effect of solution in order to have a better inference and to see if there is any difference between means of our response variable for different solutions. Is it clear? Okay. Then we said this is exactly the same hypothesis testing that we have, but the only difference is we have the effect of blocks. And we need to separate the effect of block from the effect of factor. So for that, our variation decomposition can be rewritten by this guy here, between treatment variation, between block variations, and within group variation. This part is new. So, which is SSTR, SS block, and SS error. And again, we can use these equations to find each variance component. SS of error is SS of total minus SS of treatment and blocks. And finally, we can set up our ANOVA table. And here is the degrees of freedom. For treatment is the number of levels that we have, or number of populations that we have, -1. For blocks, number of blocks that we have, -1. And for error is A minus 1, B minus 1, and total is A, B minus 1. Degrees of freedom. Then we calculate mean square error. And then we can calculate F naught, which is MS of treatment and MS of E, divided by MS of E. And we compare it with this critical value. If it is greater than that, than this threshold, we reject. Otherwise, we accept. We cannot reject H naught. Okay. Any questions so far? Yep.
What would be the significance if you were to look at the MSE for the blocks and compare that to what it looks like for the treatments? And what would that look like?
So the question is, basically, can we do the similar things for block as well? Yes, you can do that. But so what you can do, you can say another F naught, which is MS of block divided by MS of error. And you can compare this with F alpha. Instead of A minus 1, should be B minus 1. And A minus 1 times B minus 1. Okay? You can do that and say if it is greater than this threshold, then what does it imply? Anybody can tell me? So why did we define a block? Because we were concerned about exactly whether that factor could affect the homogeneity of the experiment. If this is the case, then we could say, yes, our initial guess was right. So that factor affects the homogeneity of experiment. But if not, that factor doesn't affect. So what you can do, you can go back and do one-way ANOVA. Okay? So what you can do, you can compare or do the experiment, or I'm sorry, the hypothesis testing for blocks. Compare it with this guy. If it is greater than that, then blocks are significant, which means your block is changing or affecting the homogeneity of the experiment. And this is the way that you analyze the data is the right way. However, if it is not, then maybe you can go back and do one-way ANOVA. But just be careful. Some people say sometimes this is not a very you cannot trust this test, hypothesis test. The reason is we cannot do randomization between blocks. So what I mean by that, if I go back to this very first experiment or example that we had, we can do randomization within each block, but most of the time we cannot do randomization between blocks because of the constraint that we have. Because this is one day, the other one is another day. Okay? So then they say because you cannot do the randomization between blocks, maybe that could cause some problem, and that hypothesis test may not be 100% valid. But if this is, let's say, 50, and this is 5.2, then don't worry about that. This is significant, definitely. Don't worry about the randomization problem. But if this is 5.2, the other one is 5.5, then that's a little bit worrisome. Any other questions? Yes?
An example of this is being the effect size. How is there a way to calculate what's the effect of? I mean, how large is the difference?
Oh, the effect size. Okay. So really, the effect size in more than 2 levels cannot be calculated. Okay. So what do you mean by effect size? It's related to mean square. Okay. So if you have 2 factors, then you can talk about their effect size by comparing these 2. Is that what you mean by the effect size? Yeah, so this could be related to effect size. If you want to compare A and B, the effect of factor A and the effect of factor B, you can compare basically their F naught. Okay, that could be related to the effect size. So which one has more influence, put it this way? Yes. Yeah. Did I answer your question or was something else?
I mean, also, I was wondering, like 50 you said is way greater than 5.2.
Oh, okay.
So you said that then, you don't have to worry about randomization.
Oh, yes.
So at what point do we consider?
Oh, no, that was just, there is no rule for that. So question you are asking is, I said like 50 is much greater than 5.2, then don't worry about randomization. Is there any rule to say greater than that, don't worry about it? No, there is not a rule. There is no rule like this. I thought you were asking how we can compare the effect of 2 factors, but actually this is something that sometimes we want to do. We want to compare the effect of one factor with another one. In that case, you can compare their F0. Okay. Then we had one example, and we went over that example. And finally, assumptions in 2-way ANOVA. Observations are normally distributed. How I can check that? Either histogram or normal probability plot. And the last one is goodness of fit. Normal probability plot and goodness of fit I will teach you later after we are done with regression. Observations are independent. So what is the tool? Do you remember? We should plot something versus something. You want quiz? Residuals versus what? Error and residuals are the same actually. Order. Order of experiment. Exactly. This is for independency. Variance of observation in each factor are equal. Okay? So across different factors it should be equal. So how do we test that one? Again, another plot, which is what? EIJ versus different treatments. So in the example of solution, we have 3 treatments. So we plot residuals, and if they are like their widths are sort of consistent, then we say variance is constant.
Or across
No,
all?
actually, I think it should be. Yeah, I think that's not a good wording, but it should be across different levels. Yeah, across different levels. Variance should be that. Yeah. How about the last one? EIJ versus what? Blocks. So how many blocks do we have? 1, 2, 3, 4 in that example. Because blocks were days. This is treatments are solutions. Okay? And last assumption, which is always true if we use fixed effect models, summation of tau i's are 0 and summation of beta j's are 0. Okay?
In that some of these assumptions have broken down? Or
No. So you mean the null hypothesis?
Yeah.
No. When you, so you draw some conclusion. So the question is, if we reject H null, does it imply that one of these assumptions are not valid? That's the question. No, this is not the case. When you draw a conclusion, that conclusion is separate. Okay? You want to see the procedure that basically you follow to draw that conclusion is valid or not. That procedure is based on some assumptions, and these are the assumptions. You want to check whether those assumptions are valid or not. Okay, if these assumptions are not valid, then the conclusion that you draw maybe is not valid. Any other questions? Okay. So, oops. I guess I updated, but I didn't. Let's see. I need to use TS square. Oops. Okay. I guess I need to use the PDF. Or maybe I can save it. Okay. Now, let me talk about general two-way ANOVA. We are done with two-way ANOVA. One factor is blocking. What if in some cases two factors are of interest? So we want to see whether these two factors are affecting our response or not. There is no blocking. Okay? Still we use two-way ANOVA, but there is a difference between two-way ANOVA with blocking and general two-way ANOVA. So here is one example. We want to see whether the primer type, this is basically an aircraft primer paints process. Okay, so we want to see whether the primer type and the application method would change the adhesion force. Okay, would affect the adhesion force. So what we do, we have two factors. One factor is primer type, the other one is application method. Primer type has 3 levels, and application method has 2 levels. Okay? So none of them are disturbance or nuisance factor. None of them are blocking. Both of them are of interest. We want to see whether they are affecting our response or not. So what we do, we basically do some experiments using primer type 1 deeping method. We have 3 specimens, and we measure the adhesion force. And that guy here is the summation of these 3 numbers. So how many combinations do we have? 6 combinations, and each combination has 3 replicates. So your n is 3 here. Okay? So in total, we have how many observations? 3 times 2 times 3, which is 18, probably. And as you can see, this is the summation of each row, this is the summation of each column, and this is the grand total. Similar notation that we have. But as you can see, here is a little bit different. We have 3 indexes. We have Y, I, J, K. I is the index for factor 1. J is index for factor 2. And K is index for what? Replication. Okay? So we didn't have that part in blocking. You remember we didn't have any replication. Okay? For two-way ANOVA, if 2 variables are of interest, we need to have replication. Otherwise, we cannot do the hypothesis testing. I will tell you why. Any questions so far? The problem statement is clear. So what we want to do, we want to see if factor A is, or factor 1 in this case, is significant. Which means mu for factor 1, mu 1, 1 is the same as mu 1, 2 is the same as mu 1, 3. Okay, that's what we want to see. What is mu? Anybody can tell me? What is mu 1, 1? Yeah, the adhesion force. The average of adhesion force for the first level of primer, factor 1 is primer, is the mean for the primer 1 and primer 2 and primer 3 are the same or not. If the mean for these primer are the same, it means that factor is not significant or not influential. Does it make sense? Again, if the mean for primer 1 and primer 2 and primer 3 is the same, means primer is not a significant factor. Okay? That's one hypothesis test. This is H null. And H alternative is otherwise. No, primer type is factor 1. Application method is factor 2. So factor 1 is primer type. Factor 2 is application method. Okay?
Yeah.
What is it?
Or just 1, 1, 1, 2, and no 1, 3, because there's only, just based on notation for your means.
The subscripts.
Oh, no, this is Y. This is observation. I'm talking about means. That's different.
Well, I was thinking that you said the I part of the subscript was primer type. Is that false? So then mu 1, 1 would equal, you were looking at,
No, this index has nothing to do with this guy.
nothing to do
No,
with
this
this.
is for each observation. I just want to show you. So maybe you can drop that index. That would be easier to understand. So whether mu1, mu2, mu3. So different levels of basically factor 1. For factor 2, H naught is whether mu1 is the same as mu2. Okay? Or mu1 is not the same as mu2. Which means this is for basically primer. This is for application. So basically, the mean of your adhesion force for dipping method and a spraying method is the same or not. Okay? That's two types of hypothesis. There is another one, the third hypothesis test that we want to do, and I'll tell you what this is. Okay? Any questions? Okay. Now, so here is the general table that we have. So each level, this is kind of like factor A in A levels, factor B with B levels, and each treatment combination has N replications. Okay? And this is basically the model that we are using. So model is like that. So your Yij, K. So each observation in cell Ij. Okay? Cell Ij, I mean, let's say cell 1,1 is this guy. Cell 1,2 is this guy. Is coming from overall mean plus the effect of what? Factor 1, the effect of factor B or 2, and there is something called interaction effect. I'll tell you what it means, and some random noises. Does it make sense? So what is the difference between block model and this model? The interaction effect. So here is the interaction effect. In block model, we assume there is no interaction between block and the other factor. Okay? Any questions so far? Are we good? So basically, I can write down my hypothesis here for factor 1, whether tau 1 is equal to tau 2 is equal to tau 3 equal to 0. This is H naught. And alternative is otherwise. For the second factor, I can write it as beta 1 is equal to beta 2, and otherwise. And there is another one I can write for tau beta, the interaction. Tau beta ij's are, this should be 0. All of them are 0, or at least some of them are non-zero. So actually it's tau beta 1, 1, tau beta 1, 2, tau beta 1, 3. So how many combinations do we have? Probably here in this example, 6. Does it make sense? Okay. Now let me tell you what the interaction effect is. So let me jump a couple of slides. Yeah. This actually shows what basically interaction effect is. So let's say this plot called interaction plot. Okay? So in this plot, as you can see, in x-axis we have primer type. In y-axis we have response, which is for adhesion force. Okay? So at primer type level 1, let's say the application method is dip. So we want to see what is the effect of primer type when we have application, dip application. I mean, application method is dip. Okay? So what we do, if I go back to the data here, so that's these numbers, 12.8. So primer type 1 dipping application, that cell. Okay? Divided by 3, it's around 4.2. So that's the average of cell 1, 1. Okay? This is the average of cell 1, 2. Actually, 2, 1, sorry. And this is the average of 3, 1. Okay? So what does it show? Can I say this curve here is what? The effect of primer on response or force, adhesion force, when I'm using dip method. Does it make sense? The effect of primer type when I'm using dip method on the response, which is the adhesion force. So what is this guy here? Is the effect of primer type on response when I'm using a spray method. Okay? So if these two are similar, it means the effect of primer type does not depend on the level of or the method of the application method. There is no interaction effect. Again, if the behavior of these curves are the same or similar, then I could say the effect of one factor, which is primer type, does not depend on the level of other factor. Okay? No, if they are similar, then there is an interaction effect. Okay? So the effect of, let's say if the curve was something like this. Okay? This is for dip, and this is for spray. Okay? Then you can see primer 1, 2, 3. When you are using dipping method, okay, by changing your primer from 1 to 2, you are decreasing your adhesion force. From 2 to 3, you are increasing it. However, if you are using a spray method, the effect is the other way around. Okay? So this is called interaction. So you cannot judge the effect of one factor without considering the other one. Does it make sense? So that's what we're trying to basically measure and do the hypothesis test for. Okay? So based on this figure, what would be your guess? Interaction is significant or not? Probably not, because the effect is similar. And we will see if hypothesis testing tell us the same thing or not. Okay? Any questions so far? Is the model clear? No. The conclusion is based on hypothesis testing. But this gives you some idea. It's just a visual tool. It's like descriptive statistics versus inferential statistics. Okay, let's see. That's the model, as I said. Again, I is from 1 to A, J is from 1 to B, and K is from 1 to N, which is the number of replications. Then we have ANOVA table. Source of variation could be A, B, interaction, which is AB, and error and total. So this one is new. We didn't have this before. So degrees of freedom, A minus 1. A is the number of levels. In this case is what? 3. 3 minus 1, 2. B minus 1. In this case, 2 minus 1. A minus 1 times B minus 1. Error is AB, N minus 1, and this is total. You can calculate mean square, and in this case, you have 3F0. You want to see whether factor A is significant, factor B is significant, and interaction is significant. So you need to have 3 hypothesis testing. That's why you have 3F0. And you compare F0 with their corresponding the threshold, which is F alpha A minus 1, A B N minus 1. That's for factor A. F alpha B minus 1, A B N minus 1. And F alpha A minus 1, B minus 1, A B N minus 1. Why? Because as you can see, for the first one, the degrees of freedom is A minus 1 divided by MSE, which is ABN minus 1. For the second one, is B minus 1 divided by MSE again, which is this guy. For the third one is this guy divided by this guy. So that's why we have these thresholds. Any questions? Yes?
3, it's the number of replications in each cell, right? Not the
Yes, exactly.
number of-
So n, the question is what n exactly is. N is in each cell, how many replications do you have? Yeah, that's correct. And can you tell me now why n cannot be 1? Why do we need to have replication? Look at the table. ANOVA table. What?
0.
Degrees of freedom for error is going to be 0 in that case. So which means there is no error, which means there is no denominator. So you cannot do the hypothesis test. Okay? But in blocking, we didn't have any errors. I'm sorry, we didn't have any replications. But we were able to do that. Why? Yes.
From day to day.
Yes. So in terms of model, what happens in basically in terms of the model structure and ANOVA table? What is the difference between them? We didn't have any n over there. So for blocking, that was the model, if you remember. Okay? Any guess why it works for blocking without, I mean, no replication works for blocking, but it doesn't work here? The reason is this guy. For blocking, we don't have any interaction effect. So that interaction effect is just the error. So epsilon ij, tau beta ij. So basically what we are calculating in blocking is this guy. What we are calculating in blocking as error is this guy. Okay? So that's why the most important assumption in blocking is there is no interaction effect. When there is no interaction effect, then you can consider that part as error of experiment, which is right here. Okay? It's just some extra information. So, but if you have questions, let me know. Okay? So how we can calculate? How we can calculate main effect? The components of our hypothesis testing or ANOVA table. This is the equation for SST, SSA, SSP, and interaction, and this is SS error. So let's continue with example, primary experiment. So these are the data. SST, as you can see, is each variable squared minus the grand mean. Let me see if I can. Oops, too much. I think that's the best we can get. The grand total, which is this guy, squared divided by ABN. ABN is 18 because 3 times 2 times 3. So we get SST. SS primer, we can calculate it. SS method, or application method, we can calculate. And interaction also. And SS of error. Okay? These are all based on the equations that we had here. Okay? It's easy to calculate. So then, using this information, we can have our ANOVA table set up. This is the ANOVA table. So sum of a square for primer type, 4.58. What is the degrees of freedom? degrees of freedom is a minus 1, 3 minus 1, which is 2. For application method, degrees of freedom is 2 minus 1. For interaction is a minus 1 times b minus 1, which is 2 again. That's all observations that I have, abn times abn minus 1 for total, which is 2 times 3 times 2 minus 1. I'm sorry, minus 3 minus 1, which is 17. And for error is a, b, n minus 1, which is 2 times 3 times 2, which is 12. Okay. Then we can calculate mean square, s square divided by degrees of freedom. So we have 3f0. We need to compare the first f0 with a minus 1, which is what? 2, abn minus 1, 12. So f of 0.05, 2 and 12 degrees of freedom, I think I already have it here, is 3.89. The other one is 1, 12. So that guy is 4.795 actually. And this is, again, is 3.89. Why? Because this is 2, this is 12. Okay? Now we should compare our F naught with these critical values. And as you can see, the first one is greater than, so significant. So what is the conclusion? Primer types indeed affects your adhesion force. Okay? How about application methods? F0 is greater than 4.75. Again, it affects your adhesion force. Interaction, would it affect or not? 1.46 is less than 3.89. It doesn't affect. So interaction is not significant. The main effects are significant. That's basically aligned with what we saw in the interaction plot. Any questions? Oh, good. Yeah.
Mean cell is not, has to be equal. What if, if in a real experiment we are not able to replicate?
Yeah, so the question is, what if based on lack of resources or limited resources that we have, we cannot go with n greater than 1. So there are some methods we don't cover in this class, which, if I remember correctly, it's called 2 keys, 1 degrees of freedom test. It's in design of experiment class. You can see that. Yeah, you had a different question? So I think we cannot communicate. Oh, but okay, sorry. Yeah, please speak up a little bit. So what if n is not equal itself? Then you can basically just go with you remember for one-way factor how we had the ni. So instead of n, we had ni. So you can replace n with ni. Okay, and in this case, this would be ABN minus AB. You replace ABN by capital N. And in this case, again, ABN by capital N. And capital N means the total number of observations. How many observations that you have. Okay? In equations, so this ABN replaced by capital N. Whenever you have, for example, here, again, capital N. And here, the summation, you have n here. It should be replaced by ni every time that you have. So basically, I think it would be better. I'll try to give you a set of equations with variable n. That would be easier. I'll post it on T-square when n is variable. So you just replace n with ni, and instead of ABN, you use capital N. But the procedure doesn't change. The calculation is changing. Question?
Experiments, how do we decide whether we should say if you're doing multiple days, like there might be other measures like temperature and stuff. So how do we measure? We go for like a blocking kind of method, or like consider the J as a factor?
So actually, what is the main purpose of the study? Okay. In this case, the main purpose of a study is to see whether primer and application method are significant factors, how we can optimize. In the previous one, the main purpose of a study is to see whether solutions would affect your response variable or not. But blocking is something else out of your hands. It's a nuisance factor. You cannot do anything. So you are not interested in saying whether days are the same or not. So, but you cannot do all experiments in one day. That's why you need to block their effect. Does it make sense? And that's another reason that we don't care about the interaction of blocking, because this is not really the factor we are interested in. You had one question.
Oh, yeah. I was just wondering if you could just explain what blocking is again.
So,
because you just after you explained kind of why the independence assumption, and exactly where that comes in. And you were just talking about it, but
yeah, I mean the blocking. If I go back, this is for. So the question is what the blocking is. Where is that? So blocking is defined here. So sometimes you want to investigate the effect of one factor. In this example, we want to see, we have three different solutions. We want to see if the effect of these three solutions are the same or not. Okay? But because of the limited resources that we have or the length of the experiment, we cannot perform all experiments in one day. Okay? So what happens, we have some experiment in the first day, some experiment in the second day, and so on and so forth. Okay? Does it make sense? Now, the question is, that could affect the homogeneity of your experiment. Why? Because the condition in day 1 and day 2. So that day is a kind of nuisance factor. You want to remove the effect of that nuisance factor from your experiment. This is called a block factor, and this model is called blocking model. Yes, that one is this one is two-way ANOVA. Actually, this blocking is two-way ANOVA blocking, and the other one is two-way ANOVA with interaction. So conceptually, they are different because in the second one, you have two variables of interest. You want to see whether these two are affecting your response or not. In the first one, you have only one factor of interest, and the other one is nuisance factor. It's a noise, or it's a block factor that would affect the homogeneity of the experiment. Okay? They're conceptually different. Yes?
The generalized case,
Yeah.
if I think in that example, n was 3, and say we wanted to do 6 measurements, and you could only do 3 per day, is that too much? Like you've added a blocking factor to your generalized case, so you can't do anything, or can you?
That's actually a good question. In general, the question is, what if we have two factors of interest and one blocking? Is that the question that you have? Yes, we can do this experiment, but not in this class. Again, this is just, as I said, this course is some basically basics for taking other courses. So with that information, you are ready to take design of experiment class, which is all about different situations, like how we can use like blocking when we have more than two factors and stuff like that. And with the regression that I teach in this class, then you are ready to take the regression class. So these are just the basics to know what ANOVA is, what regression is. Okay? And hypothesis testing is basically like alphabet. It's necessary for everything. Yeah.
Take the mean of each cell and turn it into a two-way blocked ANOVA by removing your ends, and you just treat one or two.
No,
like
I mean, in terms of, if you are talking about generating a table for two-way, Yes, but my concern is they are conceptually different. So if you are interested in two variables, you need to do generalize. If you are interested in one variable and you have one basically noise factor, you need to do block. Okay?
Is similar to the formula for error in our blocked ANOVA.
That's actually, it's not a coincidence. That's why, so actually that's a very good point. You mean the SSE here? Exactly. They are the same for a reason. So that's why I'm saying this is kind of error in your blocking. That's why the equation is very similar. Yeah. The degrees of freedom actually are the same. Any other questions? We only have 4 minutes, but let me start with regression. Just give you some idea what regression is about. I'm sure you know that. But anyways, so regression, we start with linear regression. You know that regression is used for finding the relationship between two continuous variables or one continuous, one discrete, or two discrete variables. Okay. Let me start with a very simple case when we have two continuous variables. Okay. One is called y and the other one is x. Usually we want to see the relationship between, in this example, purity and hydrogen level. There are two variables. So we start with a very simple visualization tool. It's called the scatter diagram, to see first of all if there is any relationship between these two. If there is no relationship, why bother? Okay? So a scatter diagram is, for that, we have a sample of paired observations. And in each pair, we have one value of hydrocarbon level, in this example, and purity for Y. And as you can see, this is that point. We plot this point in one graph, which is Y versus X. And we do for all other samples. And at the end of the day, this is called a scatter plot. And you can see there is a sort of positive relationship between X and Y. When X increases, Y also increases based on that. Does it make sense? How many type of relationship could have? That's the second one. This is negative correlation. Relationship means correlation. This one is what? 0. There is no correlation. How we can measure that correlation? There is something called linear correlation coefficient or Pearson correlation coefficient. That's the equation for that. That's how we can estimate it. It's similar to basically the equation of covariance and the variances. So if you use this equation, you can estimate the intensity of correlation is always between -1 and +1. Okay? And the good thing is this is dimensionless. This is unitless. Okay? Why? Because the unit of this guy is unit of x times unit of y. Denominator, also you have the unit of x, unit of y. Therefore, you can compare the correlation of two separate sets of variables because it's unitless. Question.
0 must you be to say that there's no correlation?
There are some basically rule of thumbs, and there is one hypothesis testing. I don't cover the hypothesis test in this class, but that's a good point. I can add that a slide. I have basically maybe for next time. So I need to do two things. One for ANOVA with n variable, and the other one is for testing whether rho is significant or not. But the rule of thumb is if it is less than 0.5, then probably it's not significant. But this is just a rule of thumb. So if it is negative, there is negative correlation. If it's positive correlation. And if it is close to close to 1 or -1, then you can do regression. Just one last thing. I want to ask you this question. Let's say I have this scatter plot. So what would be the value of rho if I estimate it? Just guess. What? 0, y 0. Is there any relationship between x over y? Yes, there is a relationship.
Not linear.
But it's not linear. Why? Because rho is just considering linear relationship. And that's interesting because you can see, let's say x is 0.5 here. Less than 0.5, there is a positive relationship. After 0.5, there is a negative relationship. So there is no relationship. Sometimes it goes up, sometimes it goes down. Okay? And if you calculate rho is going to be close to 0 in that case. Any questions? So we continue with regression on Friday.